Alright, in this video we're going to go over solving equations. Alright, here's your vocab. Equation, a statement that two expressions are equal. Solution of an equation, all values of a variable that make an equation true. Inverse operations, operations that undo each other, such as plus 5 and minus 5, they undo each other. Identity, an equation that is true for every value of the variable. Something like x equals x would be an identity, because regardless what you put in for x, it's going to be equal. And then a literal equation is an equation that uses at least two different letters as variables. So basically, an equation with two variables or more. Alright, here's a few properties of equality that you need to make sure you remember. Reflexive property, so A equals A. Example, 5 equals 5. Symmetric, if A equals B, then B equals A. 1/2 equals 0.5, then 0.5 equals 1/2. Transitive, if A equals B and B equals C, then A equals C. So 2.5 equals 2.5. And 2.5 equals 5 over 2, so therefore 2.5 will have to equal 5 over 2. And substitution, if A equals B, then you can replace A with B and vice versa. So if A equals B and 9 plus A equals 15, then 9 plus B also equals 15 because A equals B. All right, so make sure you write these down and remember them. You can pause the video to write those down. Properties of equality continue, so here's a few more. Addition, if A equals B, then A plus C equals B plus C. C is just some constant or variable. So if x is 12, then x plus 3 equals 12 plus 3. All right. Subtraction, if A equals B, then A minus C equals B minus C. So same thing with addition but subtraction. Multiplication, if A equals B, then A times C equals B times C. So if x equals 12, then x times 3 equals 12 times 3 because we know that x is 12. And then division, if A equals B, then A divided by C equals B divided by C, with C not being equal to 0 because you cannot divide by 0. Don't forget that. So if x equals 12, then x divided by 3 equals 12 divided by 3. Now keep in mind, this can also be written as x over 3 equals 12 over 3, so you can also write them as fractions. All right. So make sure you have these properties written down and you understand what they mean. All right, one-step equations. Let's go over an example of a one-step equation and how to solve it. So this here, it says, what is the solution of x plus 4 equals negative 12? This is an example of a one-step equation. Why is it called a one-step equation? Because it only takes one step to solve it. Subtract the negative 4 from both sides. X equals negative 16. That only took one step to solve, so therefore that is a one-step equation. Any equations that only take one step are one-step equations. So something like y minus 3 equals 7. That's also a one-step equation because plus 3 plus 3. Y equals 10, and we're done. So any equation that takes just one step is a one-step equation. All right, multi-step equations. Multi-step equations, like the name implies, take more than one step to solve them. So negative 27 plus 6y equals 3, y minus 3. This is going to take more than one step to solve it, so this is a multi-step equation. First thing I would do, let's distribute the 3. Negative 27 plus 6y equals 3y minus 3 times 3 is 9. All right. So now I would subtract the 3y. So negative 27 equals 6 minus 3 is 3y equals, now all we're left over here is negative 9. All right. Add the 27. Add the 27. 3y equals, what is that, 18? Because that's 27 minus 9, so 18. Now your final step, divide by 3. So y equals 18 divided by 3, which is 6. All right, so a multi-step equation is simply an equation that takes multiple steps to solve it. All right? And a lot of the equations you'll probably see in this class will probably more than likely be multi-step equations. They work similar to one step. You combine your variables, you bring stuff back and forth. Why do I have an equal sign there? It's supposed to be plus 3y. All right, so multi-step equations just simply take more than one step to solve. All right. Equations with no solution and identities. Now, an equation with no solution, when you get down to it and say it comes up with like 4 equals 5, well, since that's not true, that equation has no solution, so it's never true. All right, so let's look at these two equations and see if they have no solution or an identity. Let's look at them. So we have 11 plus 3x minus 7 equals 6x plus 5. All right, so let's start solving this. Well, we can combine the 11 and the 7 and get 4 plus 3x on this side equals, we can combine the 6x and the negative 3 to get 3x plus 5. All right, so now subtract the 3x from both sides. And that cancels out on both sides, so now we have 4 equals 5. Well, we know that 4 does not equal 5, so therefore, this equation has no solution, or as I like to say, this equation has no soul. Okay? It's a soulless equation. All right? Because 4 obviously does not equal 5, so therefore, this is never true. Okay? It has no solution. And if you're answering this question, it is never true. All right, let's look at this one. 6x plus 5 minus 2x equals 4 plus 4x plus 1. All right, so let's do some combining. We can combine the 6x and the 2x to get 4x plus 5 on that side. And over here we can get 4x, again, plus 5 on this side. Subtract the 5. So we have 4x equals 4x. We can subtract the 4x from both sides. And we get 0 equals 0. Now, even though this is 0 equals 0, that's technically a solution. No solution is when you get something that doesn't make sense. Here we were able to get a solution. So this here is always true. All right? This is always true. And since 0 equals 0, all right, this is also called an identity. Oops. This is also called an identity. Okay? So basically, any value of x makes the equation true, so therefore it is an identity. So regardless of the value of x we put in here, this is always going to be a true statement. All right? It's always going to be a true statement. Because if you look here, we have 4x equals 4x. Doesn't matter what x is. It's going to come out true either way. All right? So that is what always true in an identity look like. When you get the same thing on both sides of the equal sign. The same exact thing on both sides of the equal sign. It's an identity, and it's always true. All right? Last thing we're going to go over here is a literal equation. If you remember from your vocab, which you should have wrote down, a literal equation is an equation that uses at least 2 different letters as variables. Where if you look here, the equation C equals 5/9 times F minus 32 relates to temperatures in degrees F and degrees Celsius C. So here we have it solved for C. It wants to know what is F in terms of C. So we want to solve this for F equals. All right, so we want to solve it for F. All right, so first thing I would do here is I'd get rid of this fraction. Now, to get rid of that fraction, the easiest thing to do is multiply by the reciprocal or the multiplicative inverse. Same thing, 2 different names. Okay, the reciprocal or multiplicative inverse of 5/9 is 9/5. All right? So if we multiply this side by 9/5, that cancels out, and then we multiply this side by 9/5. So we have 9/5 C equals F minus 32. Next step would be to add 32 to both sides. So 9/5 C plus 32 equals F. Or to rewrite it as F equals, you just simply turn it around. 9/5 C plus 32. Okay, F equals 9/5 C plus 32. So this is an example of a literal equation. It is simply an equation that contains more than one variable. Okay, more than one variable. All right. So that's the video on solving equations. Make sure you come to class tomorrow, ready to work some problems. See you tomorrow.